Alright, so now we have moved on to section 7. Section 7 is topic 1 that we're going to start with. That's called geometric sequences. This is on page 175. Alright, on the left hand side I have the work, and then on the right hand side I have that calculator. Okay, so let's start with consider the sequence 3, 6, 12, and 24. What pattern do you notice in the sequence? So first of all, we're going to be looking at patterns, so it's just recognizing how much my numbers go up each time. And remember, in a pattern, the number has to be consistent, which means if you add by 2, you need to make sure everything adds up to 2 each time. Okay, so let's try this first one. Consider the sequence 3, 6, 12, and 24. So how do I go from a 3 to a 6? Well, 3 plus 3. Okay. And remember, if it's a pattern, it has to be the same thing. So 6 plus 3, that does not give me 12. So that doesn't work. I can't go any negatives because there's really no negatives here. Okay. What if I multiplied? Okay. What if we did 3 times what? 2. 3 times 2 is 6. 6 times what? Times 2 again gives you 12. And 12 times 2 is 24. Okay, so what's the pattern that we see? Well, the pattern is to multiply by 2. Okay, each time we multiply by 2. Okay, this is an example of a geometric sequence. Now, what a geometric sequence is that each term in the sequence is the product. So if we remember what product is, product means multiply. So each one of these today that we are working on, you are going to multiply in order to find the pattern. Okay? And it's of the previous term and some real number r. Okay? So let's look at the next part. Just like arithmetic sequences, we can represent the sequence in a table. Okay? So just to clarify, term 1, or the term number, is just the whatever number you're solving for. So if I say, hey, find the 10th term, you'd put 10 in term number. Okay? How we write it, so my first term is going to be labeled arithmetic 1, and then that term is whatever they give you. So A1 will always be 3. Okay, my first term is always 3. Now, so if I'm trying to solve for the second term, that second term is labeled A of 2, and whatever the answer is 6. Okay, so just to let you guys know, term is the same thing as answers. Okay, alright, so let's move on to here. Now if I want to write this in function notation, it would be f of 1. Well, f of 1 stands for the first term. Blank is a formula to find the second term. So how do I find the second term? F of 2. F of 3 is a formula for the, well, that's easy, third term. And then F of 4 is a formula for the fourth term. And blank is a formula to find the fifth term. Well, F of 5. Okay, so if I wanted to find, if I ever say, hey, find the 10th term, you'd put F of 10. Okay. Alright, so what's the formula here? How do we use this? How do I do this? So the formula, and there's 2 ways to solve it. One is called the recursive and one is called the explicit form. Okay. Right now we're going to start with what we call the recursive form. Okay. And that form is a of n minus 1 times your r. Okay, and I'm going to explain what that means. So a of n minus 1 is just really taking the previous term. Okay, so you're taking your previous answer, and I can write that answer in parentheses. You're taking your previous answer and you're multiplying it to the r, which is the common ratio. And basically what that means is the number you're multiplying each time. So you're taking your previous term and you're multiplying that to the r. And in this case, my formula would be written as an minus 1. And what is each number multiplying by? Well, it's multiplying by 2. So I would previous term times 2. And that's how I'd find the next number. So if I wanted to find the next number, it would be the previous term, which is 48 times 2, and that'll give me f of 6. Okay, so that's how you do recursive form. Okay, let's move on to this part. So how do we actually use it? So how can we find the 10th term of the sequence? We can use recursive process where we use the previous term. So all I have to do is use the previous term, while the previous term here is 348. So I take 84, and I multiply that by our common ratio. Our common ratio is 2. So if I use my calculator, 384 times 2, that gives me an answer of 768. Okay, so now if I want to find my 10th term, just take that number, the previous term, 768, and multiply that by the previous, or the common ratio. The common ratio is 2. So this is, if I clear this, 768 times 2. That answer is 1,536. Okay. So recursive form, we just need to use the previous term and multiply that by the ratio. Okay. Write a recursive formula that we could use to find any term in the sequence. So now we just learned recursive form, and again for this one, it's just a of n minus 1, and that formula is multiplying it by 2. Okay. So this we just created earlier, and that's just to find any term we want. Okay, we take the previous term and multiply by 2, and that is what we call the recursive formula. Okay, so now I'm going to show you the new one, the explicit formula. So turn your page, and now we can use what we call the explicit process, where we relate back to the first term. Okay, so this is called the recursive formula, and all we do is we relate it back to the previous term. The formula is a of n equals a1 times the r n minus 1. Okay, and I'm going to explain what all this is. Okay, the a of n is just your answer. Okay, it's whatever the answer is, that's your a of n. Okay, a1, we have already learned that. That's our first term. So whatever first term they give you, that's your a1. The r, we already learned that, is just the common ratio, and it's just whatever you keep multiplying by. And last thing is the n. The n stands for the term number. Okay, and that just means if I task you for the 12th term, you're going to put 12 in for n. Okay, and just let you know, this whole area right here is exponent. Exponent. Okay, so that's just an exponent. Alright, so if you can see, we have our first term, a1 is 3, so I'm definitely going to need to use 3. And then our common difference is 2. So our common ratio is 2. So if I really wanted to do this, every number is going to consist of the 3, and every number is going to consist of the 2. Okay, so it's 3 times 2 to the second power. Let's try the 9th term. Okay, so the 9th term, we start with our formula. The formula, a1, so I use 3 for a1. Okay, we're going to multiply that by what? The r. So the r is 2. And what term are we looking for? Well, we're looking for the 9th term. So I do 9 minus 1. Okay, and remember, it's in a exponent form. So all I did was, the first term was, and I highlighted the first term, is 3. So that's 3. The r is the common ratio. So that's 2. Okay, and then remember how I told you guys that this n is just the term we're looking for, and right there. That 9 is the term we're looking for. Though minus 1 will always be there. Okay? So now, if I wanted to solve this, I would do 3. So let's clear this on the calculator. 3 times 2. I'm going to do an exponent, but instead of timesing it to the power of 2, it's going to be 9 minus 1. That answer, 9 minus 1, is 8. So this answer is 768. Okay. Remember, all I did was I put this in the calculator. 9 minus 1 was 8, so that's why I put it to the power of 8. Okay, let's try the 10th term. So this time, we're going to use 3 again, because that's my A1, times the ratio. The common ratio is 2. This time I'm looking for the 10th term, so it's going to be 10 minus 1. Okay, 10 minus 1 is 9. So instead of erasing the whole thing, I'm just going to click back at my calculator, and instead of the 8, I'm going to erase it and put a 9. And that answer, 1,536. Okay. So basically what over on the right hand side is the same function notation. Well, how would I write this as a function? Well, that is 2a times a1. A1 is 3. And then this one was 2, 9 times 3. Okay. If you look right here, this is the same thing. Alright, and this explicit formula that we've been using, well, it's a of n. The first term is 3. The common ratio is 2. And depending on what number you're going to use, it's going to be n minus 1. Okay, pretty easy. It's not difficult. Let's look at how we graph it. So let's do 0. Let's do a 1 right here. Skip a line, and then skip another line, 2. Skip a line, 3. Skip 4. Skip 5. And skip to 6. Now we only go up to 6, so no need for you to go any higher. Okay. Alright, so now we're going to go up by 5s on the y-axis. So go 0 to 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, and 100. Okay, we only go up to 96, so no need to go any higher than that. Alright, so now if I wanted to graph it, the first one I'm going to graph is 1 and 3. So 1 and 3 would be somewhere low, so about right there. Next one is 2 and 6, so it's going to be a little bit higher. Okay, and then we have 3 and 12. So as you can see, this is going up a little bit. Then we go to 4 and 24. So a bigger pickup. Then 5 to 48. So 5 to 48. And 6 to 96. So 6 to 96. Oh, I messed up right here. This should be 95 and then 100. So it should be around right here at the top. Alright, if you can notice, it's not it's like half of a parabola. Okay, and that's what these are doing. This whole unit is about what we just graphed right here. They will look like kind of a half of a u. Okay, and that's what we call an exponential function, is when they have half of a u. So far this year you've learned how to graph a straight line, how to graph a parabola, and now how to graph a curve. Okay, let's move on to the let's practice. Okay, consider the sequence -2, 4, -8, and 16. First thing you need to do always, so find common ratio. Okay, we need to find the r. Okay, once I do that, everything else comes in very easily. Okay, so first thing I need to do is find my common ratio. So how do I get from a -2 to a 4? So -2 times 2, well, that's -4. So -2 times 2 is -4. And remember, we have to multiply. So I have to multiply -2, and my answer has to be a +4. Well, a negative times a negative is a positive. So what if we multiplied it by -2? So -2 times -2 does give you 4. What about 4 times -2? Well, yeah, 2 times 4 is -8. Last, -8 times -2, 16. Yeah, because a negative times a negative is a positive. So therefore, my common ratio is -2. So part A says to write a recursive formula for the sequence. So if you remember recursive, that formula is your a n minus 1 at the bottom times the r. So this formula is going to be a n minus 1 times my r is -2. Alright, now write an explicit formula. Okay, well, explicit formula is your a1 times your r and then n minus 1. I do like the explicit formula a lot better because I think it's easier to do. Okay, now, so my a1 term is -2. Then I do multiply that by my r. My r is also -2. And then we're going to have n minus 1 at the top. So these are my two forms. Again, I like to use the explicit form. It's a lot easier. So find the 12th term. Well, this is easy. If we just use the explicit form, which is this right here, let's just use that. -2 times -2. What term are we looking for? That term is 12 minus 1. So I kept everything the same, -2 times -2. The only number I changed was the n. That was the only number I changed. And that n is the number we're looking for, 12. Okay, so this becomes -2 times -2 to the power of 11, because 12 minus 1 is 11. So if I use my calculator, I put -2 times, and on this one we have to put it in parentheses. Instead of x squared, we're going to go ahead and put to the power of 11. Okay, now that answer comes out to 4,096. So the answer is 4,096, and there you go. Okay, it's actually very easy. Only thing you have to do, find the common ratio, and then use the explicit formula. Okay, that is it for this video.